Welcome. So let me go ahead and refresh you all on the learning target. I can derive all three Pythagorean identities and then apply them. Applying them will happen after this video and the examples. Alright, at the top of the organizer that you received, you have the trigonometric terms that you should know. So you should know that cosine is x, that your sine is y, that tangent is y over x, or that's the same thing as sine over cosine. You should know that secant is a reciprocal of cosine. That is also as 1 over x, or it's the same thing as 1 over cosine. Cosecant is a reciprocal of sine, which is the same as 1 over y, or 1 over sine. Cotangent is a reciprocal of tangent, so instead of y over x, it's x over y, or cosine over sine. Alright, let's go ahead and start to fill out the first identity. We talked about the first identity in today's notes. That identity is cosine squared plus sine squared equals 1. In this organizer, we're going to talk about how to derive the other two identities in variable format and then also in rich and trig form. This variable form is going to help us with the trig form. In order to connect how you can apply trigonometric functions and think of them as variables as well. So that's why we have this double-sided thing so you can compare that. So for example, cosine squared plus sine squared equals 1. That is the same thing as x squared plus y squared equals 1. So remember where this came from. This came from the unit circle. If I were to draw a right triangle into the unit circle, this right here, the length is x, the height is y, and this hypotenuse is 1 because the radius around the unit circle is 1. And thus, that's why if we use Pythagorean theorem, we have x squared plus y squared is equal to 1 squared, which is the same thing as x squared plus y squared equals 1. And we talked about how this and this are equivalent. So what are identities, first off? So first off, identities are basically equations that are true no matter what variable you plug in. So this equation is always true, provided that it is on the unit circle. This equation will actually always be true for our trig functions because sine and cosine, they're always between -1 and 1. So that's a little background. Now we're going to go ahead and discuss how we find the second Pythagorean identity. We're going to start with the variable form of the proof, and then I'm going to show you the trig form of the proof. So here is the variable form. We're going to first start off with our first trig identity, x squared plus y squared equals 1. What I'm going to do is create a new identity. How I'm going to create this new identity is first off by dividing this equation, this whole equation, by x squared. If I divide this whole equation by x squared, I might come up with a new equation. That is why I'm dividing by x squared. No other particular reason. When I divide by x squared, my next step that I'm going to do is I'm going to make sure that x squared is divided to every single component of my equation. That's what this step looks like. See how the x squared got divided to every single component of this equation? That's all I did. Next up. The next step here, what I'm going to do is I'm going to pull out this x squared. I could do that because of exponential rules. I'm going to pull out the x squared as shown in this step. The reason why I'm pulling out the x squared is so I could simplify the things inside the parentheses. Let's see, x divided by x, that's equal to 1 because anything divided by itself, it's always 1. Y over x, I can't really simplify that right here. 1 over x, I can't really simplify. So the only thing I'm going to simplify here is this part. That's showing up in red. X over x became 1. Alright, since there's nothing else I can simplify, what I'm going to do in this last step is go ahead and apply the x squareds back in here. So this x squared is going to go top bottom. 1 squared is just going to become 1. Alright, so as you can see, I started off with this original trig identity, and I came up with a new identity. This new identity is basically a new equation that's going to be true for all x, y that's on the unit circle. That's what I basically did. So this looks different, but it's technically very much the same if we were to plug in the things. All right. So now I showed you a proof of how to create a new identity using variables. Let's go ahead and now connect this to trigonometry. I'm going to start with my original Pythagorean identity. X squared plus y squared equals 1, as you know, is the same as cosine squared plus sine squared equals 1. Good. In this scenario, you saw how I divided by x squared. Over here, instead of dividing by x squared, because x is cosine, I'm going to divide the whole equation by cosine squared. Good. Now, in the same manner that I did over here, I'm going to go ahead and divide the cosine squared to every single component of my equation like so. I broke up the fractions. Now, as you can see how I did over here, I pulled out the x squared so that I could simplify the things inside the parentheses. So I'm going to go ahead and pull out the x squareds. Then, I'm going to simplify the stuff that's inside the parentheses. Cosine over cosine. Remember, anything divided by itself is equal to 1. So this for sure is going to become 1. Sine over cosine, well, I think I remember if I look at my organizer right here, if you guys look at the top of your paper, sine over cosine is defined as tangent. This right here is going to become tangent in a second. 1 over cosine, let me look back to my organizer, 1 over cosine is defined as secant. This part right here will become secant. I go ahead and I plug in and substitute using what I just did right now. This became 1, this became tangent, this became secant. Now my last step is I'm just going to go ahead and simplify. So 1 squared is going to become 1. This squared is going to be written before the theta because in trigonometry, that's how it's written. But technically, these two things mean the same thing. Finally, as you can see, we created a new identity from the original Pythagorean identity. This is my second new identity. From this, we'll be able to find out a tangent or a secant given whatever variables I give you for that. And as you can see here, I created a new identity from the original. I did the same steps, but this time thinking about trig functions as variables is what we did. So here is my second Pythagorean identity. Let's move on to the next and last Pythagorean identity. Our next and last Pythagorean identity is Pythagorean identity number 3. Again, we're going to be starting off with x squared plus y squared equals 1. Instead, on this side, instead of dividing by x squared like I did in Pythagorean identity number 2, I'm going to divide by y squared. I divide my whole equation by y squared. My next step, as I did before, I'm going to go ahead and make sure the y squared is divided to every single component in my equation. After that, I'm going to go ahead and pull out the squares by exponential rules and then simplify whatever is inside the parentheses. I can't really simplify x over y. I can simplify y over y. I can't simplify 1 over y. So the only thing I can simplify is this right here. That's going to become 1 because y divided by y is 1. Alright, so I can't simplify these. 1 squared is just going to become 1. And then in my next step, I'm just going to put the squareds back in because I couldn't simplify these. Alright, as you can see, I started off with my original identity right here, and I created a new identity. It looks very different from the last one. So, following the same steps, I'm going to recreate the third Pythagorean identity, but again, using trigonometric functions instead of x and y. So again, let's start off with our original cosine squared plus sine squared equals 1. Instead of dividing by y squared, we're going to be dividing by sine squared because sine is equal to y. Now, the sine squared is going to be divided to every single component in my equation because that is how we break up this fraction. Next up, as I did over here, I'm going to pull out the squared. Then, I'm going to simplify whatever is inside my parentheses. Right here, I already noticed sine over sine. That is going to for sure become 1 because anything divided by itself is 1. So that's going to be very easy. Here, I'm going to go ahead and take a look at the terms that I gave you on top of your organizer. Cosine over sine, that is right here. That is going to become cotangent right here. This will become cotangent. This will become 1. 1 over sine is cosecant. So this right here will become cosecant. Let's go ahead and plug in that stuff we just found out. The next step, I'm going to go ahead and simplify. 1 squared just becomes 1. And here I'm just going to go ahead and put the squared before the thetas, because that's just how it's conventionally written in math. And there is my new and third Pythagorean identity. So I'm going to go ahead and write that in right there. So those were the 3 Pythagorean identities. Feel free to review this video to review how we got this. And also, if you're struggling with this, make sure you do come by to office hours to get some help. Let's go ahead and X you out. I would like you to move on to the examples that should be on a separate video.